We are still looking at the usage of the mass spectrum, and we are looking at the uses qualitatively. Now, there are terms that we shouldn't go without knowing what they are. One is relative abundance. Relative abundance is the percentage proportion of each isotopic mass of a given sample. That when you get the percentage, how much in percentage form does this given atom have in a given sample? Then we have another term called relative intensity, or you can call this one relative abundance. So what is relative abundance? It is the ratio of abundance to isotopic mass of an element. Now let's look at example 2. Let's look at example 2. Example 2 says, when chlorine was analyzed, the spectrum below was obtained. The spectrum below was obtained. The spectrum below was obtained. Now, let's look at the spectrum that was obtained. This is isotopic mass. This is isotopic mass. This is percentage abundance. Percentage abundance. This corresponds to 35. This is the same thing. This corresponds to 37, and the abundance is 25. And then we have isotopic mass 72. Rather 70. Then we also have 72. We have another peak corresponding to 74. Now the question is, explain the spectrum. Explain the spectrum. Now, what do we see on this spectrum of ours? We realize that we have very many isotopic masses. And we know that chlorine is isotopic and chlorine molecule is diatomic. So when we are analyzing a chlorine molecule, it is possible that since it is diatomic, like we have chlorine 35, we have chlorine 37, it is possible that chlorine 35 and chlorine 35 can combine to give a molecule of chlorine. Then also, the peak at 72 would correspond to chlorine 35 and chlorine 37, and then the peak at oral isotopic mass 74 corresponds to chlorine 37, chlorine 37. So let's answer that question. We shall answer this question by saying that chlorine is diatomic, and exhibits isotopy. It exists as a chlorine 35 and chlorine 37. Okay? And then chlorine 35 is 75% abundant, 75% abundant, and chlorine 37 is 25% abundant. Good. The isotopic mass, 70, 72, and 74 correspond to the molecular ions of chlorine 35, then chlorine 35 and chlorine 37, and then chlorine 37. Now when you analyze that, or when you realize that 35 plus 35, this chlorine is diatomic, it will give this isotopic mass. And then 35 plus 37 will also give this isotopic mass. Then chlorine 35 with chlorine 35 will also give us that isotopic mass. Now, let's look at one more example that we have been looking at examples that are to do with relative intensity. Now let's look at examples that have relative abundance or relative intensity. We have been looking at relative abundance. Now, this time, let's look at an example that has relative what? That has relative intensity. So, the question goes that the figure below shows the mass spectrum of magnesium. The figure below shows the mass spectrum of magnesium. Shows the mass spectrum of magnesium. Let's calculate the relative atomic mass of magnesium. Calculate the relative atomic mass of magnesium. So the spectrum is as this is intensity. Then this is mass number. This is mass number. We have a peak. At sorry for the noise. We have a peak at 63, at intensity 63, corresponding to mass 24. Then mass number 25 corresponds to 8.1, and then mass number 26 corresponding to 9.2. So our question here is that we should determine the relative atomic mass of magnesium. We should determine the relative atomic mass of magnesium. Now, we know that relative atomic mass should be equal to the summation of relative intensity times mass number divided by total intensity So this formula is different from the previous formulas that we have been looking at. So here we are going to say, what is the total intensity? Let's first get the total intensity here. Our total intensity is 63 plus 8.1 plus 9.1. So 63, this is 71 point, it will be 71.1 plus this, it will give us 80.2. So this gives us 80.2. So what is the relative intensity here? The summations, this will be, this is equal to 63 times 24 bracket plus 8.1 times 25 plus 9.1 times 26 divided by 80.2. And from your calculator, you should be able to get a value like that. And that is the relative atomic mass of magnesium. And we know that magnesium is 24.3. Even if you go to the periodic table, you can go to the periodic table and you do what? And you confirm. So we're going to look at one more example in the next video. Let's stop here for now.